Last time we created a simple camera that just offsets all the tiles in our scene by the camera's position. This time we'll create a better camera that follows a player and has a bit of smoothness to its movement. We also need to clamp it to the bounds of our map so it stops when the player reaches the edges. But first, I want to point out a little mistake I made in the last video. I implied that you should check if the tile ID is greater than or equal to 0 before you draw it, but actually it should just be greater than 0. And the reason for this mistake is, if you look in the tile editor, I thought the first tile's ID was 0 because that's what it is in the tile editor, but actually when you export it out to Lua, you see tiled is smart enough to make up for Lua's one base to raise, and it actually offsets all of the tile IDs by 1. So the first tile's ID will actually be 1, and anything beneath that won't be drawn. Okay, so now that that's out of the way, let's get on with the show. I want my camera to follow the player, but first I need a player. Well, I've gone ahead and created this separate file, player.lua, and I've created a player class here. Now, originally I was going to draw the player with a separate tile sheet, but if we look at our main tile sheet, our good friend Kenney actually included some characters. So we have here this one, which is tile ID 24, and then this is 25, 26. Now I've gone ahead and created this table of frames here in the player constructor. So every time you create a new player, you're going to get these frames. So we have up, which is going to be tile 26, down, which is tile 25, and so on. And then finally, I also have this current frame, which is being set to down by default. Now, if we look at the player's update function, so just like with our camera before, we're controlling the player with the W, S, A, and D keys. But not only are we offsetting the player's position, but we're also setting the current frame to the appropriate direction frame. And then we're drawing that here in our render function. So in addition to drawing our tiles texture, we're also drawing the player's current frame, which is the appropriate quad right here. And then we're also offsetting the player's position by the camera's position. So we're drawing the player relative to the camera, just like we were doing with our tiles before. Let's go back to our main file and add the player. So here I'm going to put require player, and now we need a new instance of the player. So right beneath the camera here, I'm going to do gPlayer equals player new, and I'll set his position to 64 by 64. And before I forget, I'm going to update the player. So before updating the camera, I'm going to do gPlayer update and pass in delta time, and I'm going to render the player. Okay, so back here in our update camera code, I no longer need any of this because I'm going to be moving the player now. And what I could do is I could say the camera's position equals the player's position, but that's generally not a good practice because you might want to move the camera independently of the player. Like you might have a cutscene and you want to pan the camera differently and stuff, or focus on an NPC or something. So what I'm going to do is actually create a target property for the camera. So here in gCamera I'm going to do a target position, and then I'm going to set that to the player's position. Okay, and then I'm going to set the camera's position to its own target. Okay, that should do it. Let's save that and see how it looks. Okay, well, it appears to be working. We got the frames updating correctly, and the camera is now following the player. But obviously it doesn't look right because the player is in the top left corner of the screen. Or should I say the camera is in the top left corner of the screen. So what we need to do now is actually push the camera halfway into the screen after it's set to its target. So let's try that. So back in our code, I'm going to do minus screen width times 0.5, so half of the screen width, and then I'm going to do half of the screen height. Okay, save that. Let's see how that looks. Okay, much better. So now the camera is centered in our viewport, which is exactly what we want, I think. But you may have noticed that the camera does not clamp to the bounds of the map. So the camera can actually go outside the map. You know, that might be something you want, but generally it's not something I want. So let's see how we can clamp that. We'll do the top and the left first, which is thankfully very easy. All we need to do is check if the camera's X or Y is below 0, and if they are, set them back to 0. So back here in my update camera function, I'm going to check to see if the camera's X is less than 0, and if it is, set it back to 0. And we'll do the same for the Y. Okay, save that and let's see how that looks. Okay, well you can see the camera is not going past 0, but if we move away from the edge of the screen, the camera then starts to follow, which is exactly what we want. So now we have to do the right and the bottom, and that's a little trickier. That's a little trickier because we have to calculate the total pixel width of the map, and then we need to subtract from that the screen width. Now thankfully we've already done part of that. If you remember from last time, we have here this property, this dot screen width equals this dot width times the cell size. So the number of tiles width-wise times the tile size. So we already have that. So all we need to do is just check to see. So if gcamera.x is greater than gmap.screenWidth minus screen width, the actual display width, and if it is, then we need to set gcamera's x to that value. And we'll do the same for the y. Okay, let's see if that works. And there we go. It's now clamping to the bounds of the screen properly. Okay. But you know, just having the camera following the player exactly like this one-to-one is okay, but I want to give my camera a little bit of smoothing. So to smooth out my camera movement, I'm going to use what's known as a lerp. So I'll paste in a lerp function. Now if you don't know what a lerp is, I certainly recommend looking it up. But basically what this is going to do is it's going to take a start value and an end value, and then it's going to move from one to the other over a period of time. So it just smoothly interpolates between the two. So I'm going to put that right here in my update camera. So instead of setting target to the player directly, I'm going to do gcamera.targetx, gcamera.targety equals lerp vector2. Because you have to remember this function actually returns two values, an x and a y. So we can do it this way. And we need a start. Well, that's just going to be gcamera.targetx and gcamera.targety. And what is the destination going to be? Well, of course that's going to be the player. Okay, and we finally need a time value. Well, we don't have a time value yet, so I'm actually going to quickly add one to the camera here. So I'll just make it called T. So I can just do gcamera.t. That's not doing anything right now, so we need to update that as well. So gcamera.t equals gcamera.t plus delta time. And we also want to multiply that by a small value, just so that we move slowly or slower to the position. But we have one problem here. We don't want this whole value to exceed 1, because then it's just going to shoot past the target, because this is constantly having delta time added to it. So what we need to do is clamp that. So I'll do math.min 1. Okay. So what that's saying is this should not exceed 1. Okay, so I'm going to save that and see how that looks. Okay. Well, it's very hard to see. What I'm going to do is just change that value so it's a little more noticeable. So I'll make that 2. Yeah. There. I mean, it might be hard to see in the video, but the camera is just slowly catching up with the player, which is exactly what we want. Okay. There's one other problem I'd like to address with this camera system. Well, I mentioned in the last video that we're drawing every single tile in the map, but we don't actually want to do that. We just want to draw whatever tiles are on screen at any given time. The first thing I want to do is actually change the window size. So I'm going to make it 1280 by 960. Why? Because both of these values divided by 64 will give us an even value. So we'll have 20 tiles across and 15 tiles down. Now back here, we need to, well, we're right now rendering every single tile in the whole map. We don't want that anymore. We just want whatever's on screen. So that's going to be 15 down and 20 across now. Just hard code that in. And what we want is actually whichever tile is currently in the same position as the camera. Because let's assume that the camera is still in the top left corner of the screen. So we want the top left tile. So to do that, we're going to make a new value, tx, and it's going to be the camera's position divided by the tile size. And we need to round that down, so I'll do math.floor, because we don't want this to be a decimal value. And we'll do the same thing for the y. Okay, so now instead of passing into get tile, column, and row, I'm going to pass in tx and ty. But of course that's only going to draw the top left tile. We need to draw all of these, so what I actually need to do still is I need to do tx equals tx plus the columns. And the same for the y. Okay. And of course we need to do the same thing for the other layer. Let's see how that looks. Okay, now, I mean, it's kind of working. Kind of. It's sort of drawing everything in a choppy way. And the reason for that is because there actually should be an extra value being added to the tiles. And what is that extra value going to be? Well, if we go back here, we have it being offset by the camera. But actually what we need is to offset that by gcamera.x modulus self.cell size. So that's going to offset it by the remainder of the cell size, the camera being divided by the cell size. And that gives us that little extra bit that we need to add between the tiles. So let's just see if that works. Oh, there you go. It's now drawing correctly. And the beautiful thing is we're only drawing exactly what we need now. So now our map is much more optimized than before. We're not just drawing every single tile on screen, and it clamps to the camera clamps to the bounds of the map, which is beautiful. You can't really see it, but there's some smoothing there, so I think we have most of what we need for a game now. But of course we don't want our player to go through walls and things. You know, we want some kind of collision detection, some physics. So I think we'll do that in the next video. I'll show you how we can take that physics system, which I've already talked about, and load it from a tiled map file. And, you know, if there's time, we'll also do some entity loading as well. Well, I hope you found this video useful. Please like and subscribe. Thank you. Have a nice day.